Okay, thank you. All right, so I'm Arthur Frankel. I'm the founding the person who founded Solution Street and a managing partner at Solution Street. And here at Solution Street, we're always looking into technologies and looking for what works best for our clients. And so a few months ago, I started looking into GraphQL, like probably most of you here. I've heard about it. I don't know what it was. Should I be using it? Should we be using it? And so I tried to do a little bit of an in-depth view of GraphQL. First, let me ask, how many people have used GraphQL before? Show of hands. Just 2, 3. Okay, you can correct me. Feel free to correct me if I say something wrong. This is a learning session for all of us. I don't want to share incorrect information. How many people have used REST calls? Okay, good. All right, that will be very useful. So today I'm going to give an intro to GraphQL of what I've learned. I'll compare it to REST. And then later I'll show sort of a demo of GraphQL. And then later I'll open up the discussion to everyone here just to talk about, hey, should we be using GraphQL as a community? Is it better than REST? When should we use it? When should we not use it? So I'll just do that. So first, how did we get here? So the origin of GraphQL, I think some of you may already know, even if you don't know GraphQL, it was developed by Facebook internally in 2012. It was shared publicly in 2015. And it really was to solve the issue of building a server component that works with both web and mobile. I just read the whole slide. So if you take us back to Facebook in 2012, and mobile was becoming more and more popular, mobile apps, this is before mobile was most of the internet usage. Facebook had one server, and they create, and their laptop web browser was built, and they wanted to do the same thing on mobile. So they were using the same APIs for mobile. And if you're familiar with mobile development, that doesn't work. Mobile development is different. You have less data, you have different types of data, you have caching differently. So your API usage is different. So then you have a choice of creating different APIs on the server to accommodate your different user interfaces. So hopefully that all makes sense, and you may have run into that. So internally, they developed, a couple of developers had gone off to the side and created the first generation of GraphQL, and they use it today. So that's where we came from. So GraphQL versus REST. So what's the difference? So first, let's review REST. Everyone knows REST. So separation of client and server. It's stateless. And you use HTTP verbs to define what kind of operation you perform. And based on the verb, based on the header, the path, the message body, you would send your request and you wait for your response. So again, most people here have done REST. So let's look at a simple REST call. So assume a banking application returning a specific banking transaction along with associated account name. So in a typical REST call, you have an object or resource that's coupled with the way you retrieve it. So we look at this example, and you see that we're doing a get on, this is a banking transaction, not a transaction. And you're getting the ID of 1, 2, 3, 4. You're going to return that transaction, that banking transaction, right? And so here we have decided on the server to denormalize some of the data. So how many people have denormalized the data for their REST calls? Okay, and so why did you denormalize the data? Anyone who wants to answer that? Say that again? Pull less over the wire, less calls. Okay, so that's what we're doing here. And this is a typical REST call. Okay. Any questions about this? So now let's review GraphQL. So GraphQL is really an extension of REST. The key difference is that the resource is decoupled from the way you retrieve it. With REST, they are coupled. With GraphQL, they're decoupled. So the server doesn't change in that case. And it's very powerful because the user can actually, the client can dictate what the client wants. So is GraphQL the same as a graph database? The answer is no. Those are two separate things. You'll think it may be the same, but there's some similarities underneath the covers. But GraphQL is really just another way to have an API. What's that? Yeah. To interact, you could interact with a graph database with a GraphQL API, but they're two separate things. And so currently, a lot of people are using GraphQL to interact with a relational database, not necessarily a graph database, although you can do that as well. So in GraphQL, let's take a look at this example. And in my presentation, I'm going to use this fictitious banking application. So you think of a bank that has customers, has accounts, and has banking transactions, right? You go to your bank, you could have a joint account, two customers have a joint account, and then that account has transactions of credits and debits, essentially deposits and withdrawals. So in this case, we're defining the GraphQL resources and actions separately. So if you look up here on line 1 to 6, that is our transaction object or record. 7 to 12 is our account. And so it's defining the fields in those objects, in those resources. This is very readable, so everyone here should sort of understand what's going on here. The explanation point at the end is really just notation that means it cannot be null. It's required. At the bottom, we're saying that you're allowing the type of query that you could query transactions and you could query accounts. So we're defining, in this case, we're defining that you could query a specific transaction or a specific account. And then on the server, you're required to implement that. So let's take it to the next step here. So if we're doing a simple GraphQL call, and this is just using a basic, let's say, curl statement to get the information. Here we're doing a get, which is a get HTTP verb get, to a generic GraphQL URL. And we're passing in the query of what we want. And you can see here that it's not dependent like REST on the URL path or what's in the path. Instead, it's dependent on what the client passes in. So in this case, the client's saying, and you can see this on line 1, the client is saying, I want the transaction resource, object, data, whatever you want to call it, with the ID of 1234. And I want the specific attributes of date and amount. And then I want the parent of that, its owning account. And from that owning account, I want name. So you have the choice on the client to do what you want. And the result is the same of the REST call. So you're getting the same data, but you're deciding what you want dynamically or at will. Everyone on board with that? Good. All right, so why use GraphQL? So let's use a business example. Before we get to that, the reason, what do we already know? So we already know that the client can define fields and the hierarchy, right? So in this transaction and account case, the client is defining the fields and the hierarchy because they want the two objects without changing the server or multiple calls to the server. So let's look at a business example. Like I said, let's take this fictitious banking example. This is sort of an object model. Don't give me negative credit for not having a purist one. But you can see here that we have a customer. Think of you're a customer at a bank. And the customer, because of the arrows between customer and account, is a many-to-many relationship. So I have many-to-many between customer and accounts because a customer could have many accounts. Accounts could belong to many customers. Yeah. And then account could have 0 or more transactions, right? So for that account, you're doing as many withdrawals and deposits as you can. And around these objects are just some sample data. Here it's referencing me as the customer and then my checking account. And I did a deposit of $123.75 as a transaction. So this is just laying the framework for what many of us are doing in building systems. We have some object model that's hierarchical, sometimes complex, and we need to get data from it. So if we take this further And now you're responsible for developing a web page. You're responsible for developing this web page. You need to look at the web page and say, well, what sort of data do I need? So if we take this fictitious web page, and this is not far-fetched, because if you look at your own bank, local bank, and you go online, you see something like this. So this is the top of the page. You may see welcome and your name. You may see a list of your accounts. And then you may see at the bottom of the page, if you select account or one of the accounts, you see the latest 3 transactions. Right? This is pretty typical. And so I'm just using this example to explain how GraphQL works. So what data do we need? Again, customer info, Arthur Frankel. Now, in some systems, maybe you have, because it's related to the user logged in, you may be caching that in some sense in the page. You may be doing other things, but let's assume for now you don't have that anywhere else. You need to get the account info for all accounts. So the ID, the name, and the balances. And you need the banking transaction. And in this case, we want the most recent 3 transactions for all accounts. Well, let's just say the selected account. And we need some attributes from that. So in your head, you're thinking, okay, I'm responsible for building this. I know REST. I'm awesome. How do I do that? And so how would you do that? How many calls do you need to do that with REST? So you probably need a bunch. In this case, if you wanted to retrieve the customer information alone, that's the first call. Traditional REST /customer/1, assuming my ID is 1. And then you're going to get my first and last name. And then you need to go to /customers/1 accounts to get the list of accounts and get all of that information. And then for each account, or the specific account, you need to do the third REST call that gets you the most recent 3 transactions. Now, how would you get the most recent 3 transactions? Anyone have any idea of how you would do that using REST? Okay, it's hard, right? Either people are shy or they don't know, but it's hard because usually a traditional REST call like this would return all of the transactions, right? So you have a choice. You can do that and then filter, maybe you filter on the UI, or you can make a specific REST call. You call it most recent 3 transactions, right? And you can do that too. Go ahead. And you could page it with parameters. Yes, yeah. And that's what you would do. And then, but let's say, yeah. So that is a correct answer. Yeah, you gonna say something? Okay. And let's say, so how would you implement this using REST? So how would you retrieve the most recent 3 transactions? We had some good ideas. How do you minimize the number of calls? So you have a single page that needs all of this data. Would you do 3 calls? Would you do 1 call? What would people do? Anyone? You would do 1 call. Why would you do 1 call? Why not? and let's say, yeah. The way it's supposed to be, yeah. It has to be multiple calls, but in practice, we end up not doing the pure REST. Right. And service that fits the scenario that's in play. Yeah. And so we use a hybrid. We use a hybrid approach, right? We do what seems best for performance. We weigh the costs and the efficiency, and and then let's say someone changes the UI. If you're not responsible for the design, someone changes the UI and adds additional data, or I guess if they change, they remove some of the fields that no longer needed. I guess that's okay because you're just passing it back. So what if you had different client access requiring different sets of data? So if you have mobile and web, on the mobile version of your app, you might not be able to show all of that in one page, right? So now you still need the official REST calls, and then maybe you have this one, maybe you create another one. That's a pretty common pattern. That pattern back into the front end. Yes. So we're tailoring these calls. Yeah, and that's, and we'll discuss this later. Is that okay? Right? Depends on if you just have one user interface. Maybe that's okay. If you have multiple, do you want to do that? There's pluses and minuses of doing that, right? And a lot of organizations, they change their UI more frequently than others, and they're not as CRUD oriented. They're more, dynamic in the way. So
the pattern is just you return a superset of data and the different clients grab the subsets from that at the end.
right. So now you're retrieving more data than the client needs. Maybe that's okay from a performance perspective. Maybe that's not.
The bank, right? The landing page, every single user, that page.
Right. And so, and GraphQL obviously does handle some of this a little bit better. So what are the benefits? It's hierarchical. It does let the client specify exactly what data it needs. And it uses a type system to describe the data, so the clients can understand what the possibilities are in terms of the schema and and what they could do. So how do you use GraphQL in practice? I think there were 3 people here who have used GraphQL. I'm kind of curious how they're using it. This is we're kind of ecosystem of GraphQL. There are client libraries, so the client obviously has to interact with GraphQL, and there are popular JavaScript libraries to do this. Some have bindings to React and Angular and Vue, and others are just plain JavaScript. So you need a client library, obviously, if you have a web browser or mobile app interface. There are gateways that deal with caching, monitoring, and performance tracking. And then there's the meat and potatoes of GraphQL servers that are responsible. They actually do all the work of dealing with retrieving the query and then processing it and sending back a response. And there's also what they call database to GraphQL servers. I look at this as the ORM portion. So there are ORM tools that do the translation between the database and GraphQL servers. So whether you're using a relational database or a NoSQL database or you're using a graph database, they do some of the heavy lifting, and they typically provide some out-of-the-box CRUD operations. So you don't have to write the code for that. So if you're familiar with like Rails and Active Record, it does that. I think Django has, what's Django's? ORM. Django. I think it's the ORM underneath Django. Anyway, so there's a nice GraphQL stack, which I guess I'll just swap to over here, which I really liked. And at the end of the presentation, and I'll share the presentation, I have a list of URLs to go to. But so for those, I was talking to someone earlier about what language you're using, what software language. So here, this is breaking down the ecosystem. And then, with the client, you have a choice of JavaScript and some other languages, and even some native stuff. And I'm not going to go through this too much detail. This is just to give a kind of a look. Gateways to deal with the caching and monitoring, and the actual servers that do the heavy lifting. So you can see JavaScript has several possibilities. If you get to Java, there's one, at least listed on this web page. I don't know if there's more than one. These are implementations of the, these are open source, I believe, yeah. This is the server, so I'm at the GraphQL server. So I'm just quickly going through from top to bottom, front to back, however you look at it. And then there's the ORMs, essentially. So and these are the connections to the database that offer some added ability to deal with GraphQL. So let's see. So I thought about, well, maybe I'll build live code and build the server for you, but that was going to take too long because there's a lot of concepts here. And so I'm just going to show you what I've done and describe what I'm using for the demo. So I'm using a client library. This is all in JavaScript, by the way. So I'm using a client library, Apollo, which has become a very popular GraphQL client library. And I'll show that much later. And then my GraphQL server is GraphQL Yoga. And that's taking the requests from the client and processing it. and knows how to understand GraphQL requests and knows how to deal with them. And then my ORM, my database GraphQL server, is Prisma. And Prisma is, and this is all open source, and Prisma does handles a lot of cool things in terms of it handles the CRUD processing for you. So if I'm asking for a hierarchy of my 3 objects, I don't have to write really a stitch of code in order to return whatever the client wants with those 3 objects for any of the CRUD processing, so the retrieval, the create, update, and delete. And we'll talk about that a little bit more. Any questions?
In terms of performance,
Yeah.
the real difference in performance comes when you have to join and entities.
Yes.
And not as much from how many fields of a single
That's right.
table that you're in. If I read this right, what GraphQL gives you the ability to pick and choose certain fields. I hope you can also specify that the dependencies, whether you want to retrieve a dependency or not.
Yeah.
But if you give that ability of whether or not to retrieve the dependencies to the client, then the client can kind of shoot themselves on the code without understanding the backend.
Right. So the question was, I'll just repeat it because it's recording, is assuming that GraphQL or Prisma is able to handle the different selection of attributes and the hierarchies, how deep you want to go into the hierarchy, and you give the client that power, whether it's an internal client or an external client, that you could run into problems like N+1 problems. You could run into performance issues because you're essentially giving the keys to the castle to the client. And I would say, and we're going to talk about that, and because you're really relying on your server to be much more aware of the different types of queries that you can make, and you can limit that as well. So Prisma gives you out-of-the-box CRUD processing for the world. And you could say, well, I don't want the world to be exposed. I just want X, Y, and Z to be exposed. And so you could be specific about what you're limiting, and I'll show you that. It's part of how Prisma works. I would disagree with you about the amount of data coming back. Doesn't matter too much. If you're talking about mobile and if you're talking about mobile and you're retrieving, we've implemented systems where the database tables are 500 columns, 200 columns, and you could get into a larger amount of data even within the same table. But it is a great question, and it's something I'm concerned about, is performance and giving too much away to the client.
You said CRUD operations, right? So does it also support data operations?
Right. So the question is, it supports CRUD operations? Does it support create? So in my definition of CRUD, create, C is the create portion. So it supports create, read, update, delete. Yeah. Could you do a cascading create? Yes. Yes. Yeah, and we'll see. I'll show you the schema, and let me get into I'll show you more of the demo, and you'll take a look, and if there's any questions there about it, but it provides the schema to the user, and it does do what you're talking about. There's another question? Yeah. Okay, well, let's see. So first, let's talk about some GraphQL concepts before we get into it. So these are the 3 main execution concepts for GraphQL. So again, the resource is separate from the action. And so here the actions are query, so obviously querying, retrieving data. Mutation is what they call the create, update, and delete. And then subscription, which is a typical publish and subscribe operation, which is very interesting to use because that's not typical. And the reason why these terms are highlighted or bolded is because those are the keywords you use when you're making the request. So other main concepts, and this is really the crux of GraphQL related to the database, is a schema and resolvers. So in the schema, which we'll take a look at, you're defining your objects. And GraphQL, if you have a good ORM, it will take that schema and generate your tables, like Rails and Django, and it will also generate the entire types of operations you could do. Right? And the resolvers are where you write your custom code to handle all of the types of queries that could come across. So if you're just talking CRUD, you may get all of that out of the box. You may limit the scope of what you want to open to the world. If you want different aspects of what the data you're returning, so instead of a basic search for an account, when someone does a search for an account, you want it to do a specific search. You want it to do a search based on the amount. I don't know, whatever. You have to write your own resolver for that. And you could call up to Prisma, you could call up to the ORM to say, help me out here, but you still have to write all that code. We'll take a look at that soon. So let's, for the demo, let's please pause for the station identification. I think that's our air conditioning, which should go away. So let's talk about so first I want to go through a few things, point out a few things in my code here. And quite frankly, I didn't write much code. And I want to show the sort of the beauty of GraphQL, its simplicity. So I have this, hopefully you can see it. Raise your hand if you can't see it, I'll make it bigger. It's too big, I'll make it smaller. So I just created a node server and my package.json, which I'll show, which so I'll try to call it out. So I'm using Babel. I have some environment variables because I deployed this to Heroku, so I have a dev and production. But I'm using, as I said before, I'm using GraphQL, obviously, and I'm using GraphQL Yoga as my server. That's the main line. And then I'm using Prisma as my ORM. So you can see that there. And the two main directories, for those who are familiar with JavaScript, this is Visual Studio Code, by the way, and the two main directories that are not generated or not, that are most important, are the source and Prisma. I should have called this Prisma directory DB or ORM, because that's really what it is. So if we start from, let me see what I'm supposed to talk about here. Yeah, so in my Prisma directory, my Prisma happens to be running in a Docker instance, and so that's what this Docker Compose YAML is. And then I define my data model. And I'm going to come back to the data model, but this is where I'm telling the database, this is where I'm telling my server what the model is and what to generate. In my source directory, I have my index.js, which is the server runs off the index.js. And it's a very basic index.js that says, start a new GraphQL server, and here are my resolvers. And we'll go take a look at some of the resolvers. And there's really not much to it. Okay, so I'm just starting a GraphQL server. I'm saying that my DB context is Prisma, and that's it. There's really not much there. So if I look at, let's take a look at the resolvers first. So like I said, typically if I'm going to allow a client to make queries, so in my fictitious banking application, I have three different types of objects. I have customers, accounts, and transactions. So you can think of this as, I'm either going to get all customers, well, this is not REST, but I have access to customers, accounts, transactions, and individual customer, individual account, individual transaction. And all I'm saying here is forward to Prisma. Let Prisma do its generated behind-the-scenes thing to deal with the CRUD processing. But if I wanted to do something different, I would have to write my own resolver function. So I have this commented out here. This is just an example. And hopefully everyone sort of knows JavaScript. I'm saying here, when you ask for customers, and I could do all of these operations. I could get the first three, I could skip, I could do some sort of other functions related to how I'm getting the customers. And when I have a where clause, I'm going to use I'm going to do this specific function. It doesn't matter what specifically here, but I'm going to do this other thing that Prisma doesn't do. So I'm overriding the function, the pre-function, and then I call up to Prisma. So Prisma gives me all of these bindings to do a full query on customers. And so in my custom code, and the main reason for resolvers includes the following. One is you may have authentication, right? You need to authenticate the user. This is a server. You need to authenticate the user. Second is authorization. Who can look at your customers? Who's allowed to look at your customer data? So you need authorization here. And then third is overriding the functionality and building the functionality that you need to return that data. And so I'm just giving an example here of what you might do, but this could be tremendous. You could try to limit some of the things. You could do different logic in the resolvers.
So this resolver, is it passing something like a syntax tree of the query? Are you modifying it? That part where you added the or clause?
Yes. Yeah.
Is that what you're doing, basically, like mutating the syntax?
Yeah. So the question is, yeah. So the question is, am I modifying the syntax tree? Am I mutating it before I send it on to Prisma? And the answer is yes. In this specific example, yeah, because I want to do something different than Prisma gives out of the box. I could not even do Prisma if I wanted to go directly to the database from here. Forget about Prisma. If I don't have Prisma, I have to deal with the fact that someone's asking for customers. And so if someone asks for customers, I have to deal with, and so I have to say, well, get me the customers, and then in my customer resolver, I might have to put code in here, which has nothing, that says, well, if someone asks for the accounts of customers, how do I do that? All right, I have to do a join. I have to go out and go to that table. All right, so this is where I would fully implement the code. And I don't want to get too far into that, but I wanted to show the example that by default, you could use what Prisma offers, but if you wanted to go out and do it yourself, you can, and this is where you would do it.
Another good use case for that is microservice architecture. Not going to always get query from database.
Excellent point. Yeah, and so just to restate it, so yeah, in addition to this, you may not be going after a database. In microservices, you might be going after different collections of data. It may not be a database. It may be a file system. It may be another API call to somewhere else. Exactly. So this is where you would combine all those. Any other questions? Okay. So talked about folder structure, showed index.js, resolvers, handles authentication, authorization, any business functionality. So here's a little confusing part, this last bullet point, and I'll try to explain it as best I can. And so as I mentioned before, in Prisma, if you're using something like Prisma and ORM, you're going to define your data model. And this was similar to what we saw in one of the first slides I had, but I included customer here. So I have customer, I have account, and I have transaction. And everyone should be fairly familiar with this. If you've done anything, Hibernate, I mean, any sort of ORM, you're defining your data model, ID, first name, last name, email, and you can see here, email is unique. So I'm letting the ORM do some validation on it. I have a collection of accounts within a customer. So this is my relation to my account. And then account has owners of the account, which relates back to customer, has transactions, which relates back to transaction, and then transaction has an account. So this is fairly typical if, and then there's a command that I have in my index.js that, I'm sorry, in my package.json, where I can generate, I could say get schema, that is this, where I could just generate the schema based on that. So, and there are other commands which actually generate the database for you. And so the database, let me just quickly go to that. No, it is going to that schema. It is going to, it's using that file, and then it's it's generating into this generated directory. So what it's generating from those three objects is all possibilities that you could do CRUD processing with those three. So if I look at this generated Prisma GraphQL, I'll start from the top, and I'm not going to go through the whole thing because you can see already, you can see how long that is. It's saying, well, I could ask for the account, and if I'm asking for the owners of the account, I could use a where, I could use a skip, I could do order by. I have all of these different permutations of what I could do. So it's help, and then same as transactions. And then I have different other types in here that may look, I'll get to something like, account create without owner's input. Those are different types that you could use as part of your schema. And we'll see how this works in conjunction with the GraphQL playground, which I haven't gotten to. But it defines this whole thing, right? And this goes on and on and on. And so, go ahead. This is Prisma and an ORM similar GraphQL type ORM specific. So let me restate the question: is this Prisma specific? This file datamodel.graphql, and so that's the confusing part. There's three files here, right? And that's what I'm trying to get to. The first file, if you have an ORM, which is specific to Prisma or other ORMs, you have this data model because it's supposed to help you out where you define what you want. Then Prisma generates a file wherever you want to put it, and then you decide what you want to consume. And so this last file that's in the GraphQL Yoga server, your node server that's consuming it, I essentially just copy that file into this directory. Now, the reality is you probably don't want to do that. You probably want to take the parts that you care about and put it in here so that the client only has access to do what you want them to do. So again, it's confusing because there's three files, and if you didn't use Prisma, you would write this, you would create this file similar to the way you would create this file, and you would decide what the client should have open to it, have available to it.
That's similar to
I don't know what Cayenne.
Java.
Okay.
Pointing to a database.
ORM.
Data object.
Yeah, so the question was, is similar to Cayenne. So similar to a lot of, I know in Rails there's Active Record and Django, and so you would generate, it helps generate some of the functions and bindings for you, and this also generates from the Prisma portion. I'm going to point to, okay, I have to, hopefully this works. In Prisma, my database is in Heroku, so that's why it looks like this. But let me just get the database name, otherwise I'll be looking all day for it. So, sorry if I'm flashing back and forth here. So this is my database, and it generated, let's go down to tables. Prisma generated these 5 tables. I'm not sure, well, 6 tables, relay ID. So obviously account, customer, and transaction. So, and then it also generated 2 join tables. Even though one's a one-to-many, it still generated a join table. It could have gotten away with it. Yeah. Exactly. Yeah. The question is, did it generate the database? And it generated the tables in the database. I think you have to create, there may be some commands to create the database, but it generated the tables based on it. And if I update, I'm not going to show it, maybe later I'll show it, but if I update that schema, I can generate, it's Prisma deploy is the command, and it will make the changes in the database directly to the schema. So, all right. Yeah, so you don't need to, I think the question is if you have a database already, you already created the tables, what do you do? Unfortunately, with Prisma, you probably have to at least be in sync with the join tables and some other things. Oh, can it figure out what the schema is from the database? That's a good question. I don't know the answer to that. The question was, can you figure out what the schema is from the database itself and go reverse engineering? Maybe to look into that. All right, so again, just to review, the resolvers, I think we understood, and then it is confusing. There are three. There really is only one that is the client that the server is looking at. All right, so demo. So GraphQL, some of these open source libraries have a playground, which is very useful to see if your queries are working and what you could do. So let me do that. Actually, first just realized that I left my data in my database. So I'm going to look at my cheat sheet here. I need to reset my database. Is this the database? No. Yeah, but I could run instead of deleting the data in each individual record, in each individual table, I'm just going to run a command that will reset the database, hopefully. Oh, I need to be in Prisma. That is a, what database is it? It is Postgres. Sorry, I don't think I mentioned that. I'm sure you want to do this, I'm sure. Okay, so the first thing we're going to do is I want to start my server here. npm run dev. So this is just running my GraphQL Yoga server. And the server's up. And so first, again, another confusing part. Prisma itself has its own playground. And that's what this is. I'm not going to, it's the same, looks exactly the same as GraphQL Yoga, but just pointing it out, and I have it locked down where you need an identification, but we're not going to talk about that. I'll even close that. So here is the playground for GraphQL. And this is very useful because the first thing that we'll see here is schema and docs, and now we'll get back to the schema question. So because in my code, I have this schema GraphQL that has the entire world of things you could do. Over here in this schema, it's giving all of the types that you saw in that file. And the benefit of this is that as you're typing in queries, it is checking on them. It's auto-correcting, it's doing all that. And the docs tab here shows all of the operations you could do. The queries, right? The mutations, and the subscriptions. So if we look at, for example, customer query, this is what you could do with the customer query because we said let's just bring in the whole universe of things you could do. I could search for customers based on some input, order by, I could skip after, before, first, last, and this is the data that comes back from customer, which could include counts. I could have arguments for all of these things. So it's predefining this. So let me go back to, I talked about the playground. Let's first do a mutation. Let's first create, in our banking application, we need to create two customers, right? So let's create Arthur. So I have most of these in the playground, I have tabs for most of these, but obviously you'd write them from scratch. So I'll just point out that the first word, mutation, that defines the operation you're doing. Obviously create customer, which is a function that's available. And you can see it's giving you the information on what you can type in and the data. And you always have to return at least one field from any operation. You can't not return it. So in addition to ID, I could start typing, it knows some of the other attributes. So I could also return first name. So let's say I create myself. And then I create Joel. Right? And so I'm just returning the ID here. And if I decide to try this again, I'm just going to try to create it again, I'll get a unique constraint. Because if you remember, in my, I had a unique constraint on whoops, that's the generated one, on email. All right, so it's catching that in the ORM side. All right, so now, whoops. So this is just the things I will demo, mutation create, and I'll do querying, and I'll do subscription. So first, we're creating customers, which we did, and then I attempted to create a duplicate customer, and now I'm going to create an account. Right? So if you think of the banking application, Joel and I are going to have a joint account. So let's first create, sorry if I'm toggling back and forth here. So let's create an account. We have a balance of $1,234 in it. I create the account. That's a separate function. I'm going to update the account with, here what I'm doing is, I could have created the account and associated the users in one fell swoop. Here I'm updating the account with the users, Joel and myself, and where the account ID is what I just created. So let me just change the IDs here. I created customers. I just have to grab these IDs. Obviously in code, it would be a little different. I create the account, and if I do my copy and paste correctly, I should have, right? I updated my account, and on my joint account, I have 2 owners. All right. Any questions so far? All right. So now I'm going to create a transaction. So this is pretty basic here. My account. Whoops. So I'll create a transaction. Just a deposit of $102, and I'm going to connect it to that account. I'll create 1. I'll create 2. Just quickly. Just you'll see why later. 3, 4, 5. So I'll just create 5 transactions. Okay. So now what I want to do is I want to query the stuff I just put in. So all of this should be making sense. So I do a query of customers, and yeah, sure.
If you wanted to do it with the there's something operating.
Oh, yeah. Yes. Could you create right, the question is, can you create a batch operation where you create the accounts and then right after that yes, you could do that. Yeah. I'm trying to break it down simply so we walk step by step. So then, I'm sorry, so then query customers. So first let's query the customers. Let's not do that yet. In my cheat sheet here, I have some of this, just so I don't have to type it in. Actually, I could type it in. So let's just say, let's start from scratch here. So obviously I want a query. I then want customers. And you can see the red mark means there's an error because I need to return something. Right? And I want first name. Now it's valid. There's no red mark next to it. So I at least have something. Last name. Right? So this is my query of customers. And then I want to query customers with accounts and transactions. Right? So I want the whole thing. If I do it, sorry, I missed one. Query customers with a filter. Warn me if I skip something here. So if I'm querying customers with a filter, it's pretty similar. The where clause, I'm just querying for my information. So it's just, it's all standard syntax it's all standard, you're saying is this standard GraphQL syntax or Prisma syntax? Yeah, I think it's GraphQL syntax. Yeah. Right. So then the last thing we're going to do, or not the last thing, but we're going to query customers with accounts and transactions. And so query customers, accounts, name and balance, and then the transactions within those accounts. So in our example that we created, Joel and I have, we share the joint account. So when you see me as a customer, it has my joint account, and it has all 5 of those transactions. And then you see Joel with the same joint account, and you see all 5 transactions. Question? Yeah. This is wrapping it, yeah. Right, so, yeah. Well, I think, yeah, so the question is, this has a feel like Mongo, you're returning a hierarchy of data, and it does feel like that. And I think a lot of technologies kind of, they have their pros and cons. So, Facebook does a lot of updates. So like Twitter does, exponentially more reads than writes. Facebook still does lots of reads versus writes. And so in NoSQL databases makes sense. I don't know the specifics of Facebook, whether they were trying to go towards a NoSQL database or not. But I think they recognize the fact that, yeah, they could wrap their relational database, assuming they had one, and they could provide a graph of information, depending on who needed it. Yeah. Yeah, so this should be, you could use GraphQL, obviously, with a NoSQL database, or a graph database, or anything else, or flat file. I believe so, yeah. The question is, do you have to change anything if you go to a NoSQL database? I believe with Prisma, which currently supports relational databases, I think it's really Postgres. I think they support a little bit of Mongo or NoSQL, and they're going to support Graph, like Neo4j, which is a graph database. I think the intention is you have this one file, like many ORMs, you have that schema file, and you're able to deal with different implementations. So the last thing I just want to show for question? Okay. So last thing related to this is our fictitious example of our web page. How do we do that? Even though you may have written a single REST call to deal with it, here we're querying the customer. This is my ID. Well, this is not my ID. I have to get my ID. Let's assume I need my ID. So I'm querying the customers where it's me. I'm getting my first name and last name because I need to put that on the web page. I'm now listing the accounts I have, name and balance, and I'm listing the last 3 transactions ordered by descending order. And I want the date, amount, and I think I also actually had the cleared flag on there, whether the transaction was cleared. And so here, just right now, I'm able to do that. And so if my UI changes and they want, obviously, if they want the last 4, I could do that. Actually, I'd improve to you that it's the last 3. We'll do that first. So the transactions, I have it in descending order by date. And so you see how it's powerful with GraphQL to do what you want, especially if you're defining the web page and you have to implement towards it. The next thing I want to talk about is subscription. So this is a pretty cool publish and subscribe that you see different implementations of. But let's say you wanted to, again, the keyword here is subscription. Anytime a transaction has changed created, updated, deleted, I want to get notified. That's what this is saying. So it could be anything you want, but in this particular case, that's what it is. If I press play, it's listening, because it's publish and subscribe. And so I'm subscribing to any time I create a transaction. So if I go to create a new transaction, which I'll find in my tabs here. Whoops. I create a new, whoops, I just did the same thing for it. Create transaction. If I create a new transaction and I go back to that tab, it said, hey, I just created a transaction. And that was the state. So fairly obvious, but very powerful, and you can see how that could be used in lots of different ways. This is using WebSockets. Yeah. Say that again? gRPC was also supported? Maybe, yeah. All right, so oops, before I get to negative, let's do client library usage. So I decided I also wanted to create a client just to show that. Yoga. All right, so GraphQL Yoga is your server. So it's your it's just the server handling the request. It understands how to handle a GraphQL request and be able to process it. And so it's fairly dumb in that way. I mean, it's just like your REST server, as you're saying. You could do that in the Yoga layer. Yeah, the thing that Prisma is affording you is a lot of the generation, a lot of the database specific side. So if you don't have a database, the question was, if you just want to call an API or do something else from Yoga, GraphQL Yoga, could you do that? And the answer is yes. That's where all your logic would be. If you don't have a database, you don't need Prisma, because Prisma is providing that mapping that gives you all of that. Can you repeat the question? It's deployed. So the question is, where it's a separate server. So it's deployed as in Node right now. So I just have, yeah, that's what this server is. Prisma is deployed in a Docker instance separately. Just so that the question is, could Prisma be part of the server? I've yet to figure that out. They always have it deployed elsewhere. So I need to research that. It doesn't sound like it. There may be, again, these are two implementations in JavaScript of GraphQL Server and a GraphQL ORM. There are other languages and other open source libraries that you can look at that may do different things. Yeah. Yes. So the resolver, the question is the resolver part of the Yoga layer? It is. So my resolvers are essentially saying, when I do a query, just go ahead and let Prisma do its work. But if I didn't want Prisma, if I didn't have Prisma and I just had an API, I would just define what it would do here. So this is really the meat of the logic that normally would be in any of our implementations. Yeah.
Yeah, let's assume like customer and account can come from a different message.
Right.
And so in your query, you query for customer and account and contract.
Yeah.
Now, can you still be able to map just the transactions alone?
Yeah. Yeah, so let me look at, I probably didn't show, maybe in the account I have this. So let's say, I don't think I showed this. So when you're getting account, you could define that if someone's asking for the transaction, do this. So this code is commented out, but instead, whenever I return transactions, in this case, it's just saying, do the normal thing you do, but always set clear to true, okay, for whatever reason, right? But you could see how it could do something different. It could call an API. So you're defining at every level what you need to do. All right. I think so. So the question is, the parent here, is that being chained up, as you're calling? And I think you do have access to the chain. I don't know the exact syntax, but you do have access to the chain. Any other question? Okay, so client library usage. So let me just show. Oops. I think I just have a different client file here. So in my client, this is a basic client. It took me 20 minutes to write, so nothing big. I should have implemented that fictitious banking web page. I realize now, but I just wanted to show a simple example. So here, if you move past the HTML just has a div of customers. I just want to show a list of customers, and I'm bringing in this index.js, and in index.js, I'm using Apollo Boost. Apollo is a client JavaScript library. This is a very quick and dirty example. I'm talking to my localhost 4000, which I just killed the server off to start it again. And I'm just doing a GraphQL. This is GQL statement. This is the same exact statement I would do in my playground, right? I'm asking for a query of customers' first and last name. And then this is just JavaScript. So I do the query. It makes the call to the server, and my response, I loop through, and I'm just doing a basic append of the customer first name and last name. This is nothing exciting. I think you already know what the outcome is going to be, but just so I show it, let me just, I do have to start the server again. So that, yeah, let me explain that in a second here. I think that's it. So I'm just running the dev server I ran before. And so in this one, it's also run by Node, so I'm just npm start. I think that works. So I'm just building this into a running server just to get it. So on localhost 1234, which is here. If I refresh the page, hey, okay. So nothing amazing, but I'm just showing you from a client. Thank you. As I said, I should have, if I was more prepared, I should have did the whole web page, but you could see how this could be done pretty quickly. So then, let me go back to here. So what are the negatives? Should we all switch to GraphQL? Tomorrow, go back and switch to GraphQL. It's a little hot in here. I'm sorry about that. What are the cons of using GraphQL, the negatives? So resolvers can become very complex and need to be tested thoroughly. So everything I'm bringing up here actually was brought up before, so it's good you guys are listening. So as you mentioned before, you have to control what your client is doing, and you have to test the different iterations, especially if you're going off to an API, you're going off to another database, you're doing whatever. So that's tough. That's tougher than writing a REST call that just goes to the database and returns a list of customers, right? It's still more difficult, it seems, in terms of the implementation using REST. It's harder. It just seems harder to do, right? There's a big benefit, but it seems harder. And what about N+1, right? What about performance? What about letting customers just do what they want? Prisma has, as part of it, something called Data Loader, which is an open source library that caches and helps with N+1 queries. And so I don't want to get into a full explanation. You can look up Data Loader. And it supposedly helps with dealing with those situations, that you're not going to get into runaway queries and all of that. Now, I haven't proven that one way or the other, but that's allegedly what it does. For those of you who have used GraphQL, I don't know if you've gotten to that situation. Okay, so you swapped it out. So you haven't gotten to the point where you had a production a performance issue. Oh. Swapping in small iterations. Yeah. Okay. Anyone else who's used GraphQL? So review. What did we learn? Origin of GraphQL, REST versus GraphQL, pros and cons, concepts, and you saw a demo. And so now, and just to put out there, and I'll share this. I'll share this on the meetups, so you don't have to type these in if you don't want to. So GraphQL obviously is the first is the main website. GraphQL Stack is what I showed earlier. That has a pretty cool ecosystem listing. This is the GitHub for GraphQL Yoga and the Prisma site. The Apollo GraphQL was the client, and then I went pretty fast here. And then I have my code on GitHub, the server and the client. So I'll share all this. So I think I wanted to do this because here at Solution Street, we're trying to figure out, should we use GraphQL? Does it make sense? You know, a lot of people are talking about it. Obviously, with a lot of people here, there's a lot of interest. We talked to clients, they've mentioned it. And so I wanted an open discussion on thoughts now that everyone is fully knowledgeable in GraphQL, hopefully, if you're paying attention. Should you switch to GraphQL? Should you use that instead of REST? When should you use it? When shouldn't you use it? So whoever wants to go first.
There's quite a few questions, especially from an enterprise solution. This is one thing that sometimes all queries that is just sending the same to the same URL. So from an enterprise point of view, one thing that is still good with REST is it's still good.
Yeah.
So since the URLs are different, you have different access controls, and have different management knowledge on what happens on every URL. And by combining all that in a single URL,
yeah.
In chapter 1, we have a lot of other things. Everything goes through a very different gateway.
Yeah.
And there's a lot of monitoring, especially for the security, we are still adding a lot more things to just based on the fact that it is.
Right. So the point was, you know, with REST calls, you sliced and diced it enough, and you're providing, you can monitor it and audit it at a very micro level, granular level. And GraphQL, where it is one API, it seems like maybe you can't do that. Although I would contend that when you write your servers, and at each resource level, or each query level, or each mutation level, you can define an audit or any other thing you want to do at that level. You're now pushing the onus to within that world instead of individual services. There's pluses and minuses. Certainly REST is easier in that regard. So, yeah.
We were actually having a conversation earlier, and I was telling him, I sort of put something, not GraphQL, but in GraphQL.
Yeah.
And when I had used that for internal projects, you know, you're not opening it up to the world. Drill down quickly, prototype stuff quickly. I guess, you know, where to use it, that's where I would use it. You know, putting that on the space.
Yeah. So the comment is maybe we use it internally and not, you know, and not externally, because then it's open to the public. Yeah. Steve.
It's a really good scenario, I think, because I wanted to start off by maybe saying, does everybody use REST for everything? Because it's hard, right? To squeeze like your real world requirements sometimes into like a REST is pretty strict, right, about how you set things. So a lot of times we end up doing more RPC type of service calls, and our customers are like designers like us and other people like us not giving them crazy extra data. They want our accounts with our customers operating. They don't want something more abstract. And so you write an RPC service, and you know, get accounts with it, and you write it, you publish it, and people start using it. Then somebody comes back and says, I don't want the top 3, I want the top 7. You're like, oh, you know, I didn't write it that way, and people are using that, but I'll write a top end query. So then you add that one. You still got the top 3 ones because you're versioning for your client.
Right.
And then later, somebody says, this is really inefficient for giving me more columns. And you're like, oh, but I'm already versioning that API and people are using it. So no problem, I'll make another. And then slowly, you just build up this body of stuff, of all these APIs. Like if you have these things out there for a while. And one clear connected to in this case would be, I mean, more almost than the rest of it, but that sort of RPC style one is you could be more specific about the exact information you're looking for without having, generated an artifact that you have to version and keep track of for customer base.
Yeah, that's excellent point. Versioning, you could see it either no versioning or much, much less versioning with GraphQL. Yeah.
That was the problem. So slow to adopt. We have to support 5, 6, 10 versions of that, and our solution.
Yeah.
Or if you're developing something new, you can iterate really fast off of this. You can always switch to something more permanent later once you actually have an idea how you want to use it.
Yeah. Yeah. Anyone else?
Yes, I think some of that's one of the sort of delegate a lot of responsibility on the time on the point. But I'd be sort of curious what you guys think about this market. If that, there's a lot of clients who don't know or care about that at all. They don't want to learn that. If I'm building an API and I want to tell that,
Yeah. Yeah. So, and yeah, just to repeat the point, it's if you're giving all this power to the client, and sometimes they don't want to use, they don't want that power, they don't know how to use GraphQL, and so maybe you need something else around that GraphQL client. I was talking to someone before that a lot of our clients at Solution Street require reporting, and so if any of you have built systems, you know the domino effect of that. You build the first custom report, and you're like, wow, that's great. We want the second one. And before you know it, you've built 50 custom reports. And imagine if, and then they try to go to Tableau, and they're like, well, Tableau is too expensive, right? And then, or whatever else, right? And so if you could envision with GraphQL that you're giving some power to the user, maybe you build some reporting thing with GraphQL so you don't have to create all of these custom reports. That's one of the areas I thought of. Good question. Are there report writers for GraphQL? I don't know. Does anyone who has used GraphQL know? I don't know. Good question.
The great use case for the GraphQL product is that explore ability. You give the power to the client, so they don't have to know the application upfront. You can still do that GraphQL that you show.
Yeah.
So you can explore and you can mix and match. You can explore that on the
right.
In the old red sign, you have to go to like Swagger.
Right.
Which is kind of limited, but this one you can explore and you get a better requirement.
Yeah, so just to repeat that, so for users of GraphQL, you get all of this, you get all the API information, because you see the world of things you could do. With REST, you have to use Swagger or something else, and it's more powerful. You're giving more in the hands of the user, of the business owner. In the sense, so the question, repeat the question, sir.
Explore the whole data, and based on like the different documents.
Yeah.
Putting out there, like that's a prison aspect of that. And also you have to like have a full upfront business. Actual data.
Oh, can you, right, and yeah, you can, you can add columns, so you can think of it, well, and that's why I said you're minimizing the versioning problem, but you're probably not getting rid of it. So if you think of adding columns, that's probably not a big deal, right? Adding tables, that's probably not a big deal in your hierarchy. Deleting something, that's probably different, right? So, but you can see how, and so it doesn't fully get rid of the versioning, I think, but it does help a lot.
You can lose version because it used to be that you were version of the rest calls.
Yeah.
You would change the service side code.
Right.
Now, client-side code has to go to the database. At least
If it's a breaking change.
If it's a breaking change, yeah, right. And so, yeah, I mean, how often? So the thing is, if you do a breaking change, you'll have to, the client will have to change. It moves the responsibility. Are you deleting? Are you deleting attributes when you're in production? Not typically. Maybe you do, but I agree wholeheartedly with what you're saying. It is a little. It's different. A different versioning problem.
So there's a political problem. That clients who want flexibility.
Yeah.
Didn't want to wait on server-side REST call. They've got to go. But now, database backend people are.
Well, you don't. You could just have that. You could have your server defining that if someone makes a request for that, you're going to return nothing. Right? So you created a resolver. In your case, right? You're saying I deleted this attribute from my database table. Now my client has to worry about it. But in your resolver, you would say if anyone's asking for this attribute, just return null.
Okay, so now when the clients want to change, it used to be when the clients wanted to change, the people who were writing the REST calls had to. Now, it's whenever the database people want to constructively remove something, in order to keep the client people happy, I have to have people who are in the graph.
The server code, yeah. So yeah, so you're saying if the responsibility falls to different people, which may be better or worse. Arguably, you could go either way. Right? You could say that's fine. Maybe your code should be more in the server, and you want it fully tested and all of that. So good point. Can you move the old data to the so if you So if you change it, saying if the example is you change your table to add an attribute, or, well, again, delete, is a separate thing. Usually you don't delete if you're in production and there's different things that you have to do, but yeah.
There's a deprecation option. You know that you're going to retire something.
Yeah.
You can tag it.
Oh, that's a good point. Oh, in GraphQL.
Yeah.
Yeah, so you can deprecate an attribute in your schema by saying it's no longer available. Right, you're saying in REST APIs you could deprecate as well. I think with REST APIs, like the example was given, is if you there's certain changes you make in REST using REST that you do have to version, whereas you wouldn't have to version in the same case in GraphQL. And I'm not trying to, so just to bring up other points, versioning is definitely, whether it's plus or minus, I think it's more on the plus side, but there's issues both ways. I want to bring up other thoughts for people who have.
The other one I can see very evidently, you write something as like a mobile icon. It's very good use case. That's what Facebook is want to get the GraphQL because they can dig into the thing.
Yeah.
Right.
So again, if you're building an enterprise system that has a browser based, it has a mobile app, and maybe it has just an external API, maybe GraphQL is your answer because you don't want to have different REST calls for those different 3 types of clients. Maybe, and it seems right. You're saying create different REST API calls with different views. Right. So you're a REST proponent who's saying that you want to. Right. Yeah. Yeah.
But it doesn't mean that. But I think one of the things I noticed.
Most of these calls are post.
Yeah, I mean, for Rust, you can have get post maybe any HTTP.
Yeah.
But in this case, I think mostly
well, I showed the example with the get in the beginning of a query. So yeah, and sorry, but I was just joking before about with REST, there's definitely ways that you could kind of skirt around it. And the question is, does it make sense to do some of those things, like we talked about, or does it make sense to embrace the new architecture? And is this too new? Is there performance issues? We don't know, right? Maybe there are. Right.
I'm also thinking about a hybrid model where you do a standard REST API,
Yeah.
and for sophisticated clients, they could be using, they have the option of consuming this functionality with more functions using that.
Yeah, so the point was maybe you have both. Maybe you have REST. You know, it's for the old people in here who watched Saturday Night Live. It's a floor wax and a dessert topping. Anyone laugh? Knows what I'm talking about. Yeah, maybe you have both REST and GraphQL because you have different consumers who care about different things. Yeah.
I'd be curious if you sort of looked at what all of this like one framework is. Because I'm envisioning scenarios where you could do whatever data and that does very subset GraphQL Query and then have another thing elsewhere that's sort of the whole thing. How would you manage?
Yeah, so the question is, have we looked into sort of GraphQL related to client-side libraries, popular ones like React, Angular, Vue? And so Apollo is one, and they have bindings. So let me answer it the way I think. There's bindings for those libraries. So within React and Angular and Vue, you can make calls, GraphQL calls, that are part of the framework. Now you could envision one of those components, a React component, Angular component, that maybe it's displaying that whole that major portion of the web page. So it's doing one GraphQL call, and that component is assembling those sub pieces with that one call. So you can envision the positive aspect of using GraphQL in a React or Angular component where it's making the one call and then it has some subcomponents that it's building, passing that data. Yeah, perhaps. I don't know if anyone's used React or Angular or Vue with GraphQL. Have you?
So, part of my stack is React Redux GraphQL, and it's actually reduced our development time for building a fairly complex data integration.
And why is that? So why is it reducing?
We had ever-increasing sprawl of REST API pieces because our data was structured, and we were able to basically go down to one, use query, use authentication mechanism to ensure that the client was only getting access to their data, get access to any of their data with basically one type of call.
Okay. So just to repeat, it improves the efficiency of development because you're combining things that you used to have to do separately into one, and that's good. So you're a fan of GraphQL?
Yeah.
So what do you think? When wouldn't you use GraphQL?
If things had to be very tightly coupled, I wouldn't use GraphQL.
Okay. If things have to be tightly coupled. Okay. Steve?
I think it would always make me faster. I think that could really be a product. The kind of the cautionary tale side I could imagine for this is, we've all had apps like a billion, multi-million records or something in it, and let's say somebody comes back and you're able to find out because let's say you're doing something older style, and they're giving you specifics. I need these 3 columns. I need this type of thing. I'm going to look it up in this fashion. This is going to be 60% of the traffic on the site. You might look at a particular query and say, that's going to be a table scan every time that runs. It's going to generate IO like crazy. I have 2 of those columns in an index in order already. I added the 3rd column. Wouldn't even ever hit the table. It was an ordered lookup on my index. Right. It would reduce the IO to 10,000. It would dramatically increase performance. I could scale to the moon on the database or something. And I think maybe, and you could still do that with GraphQL. GraphQL in no way precludes proper database optimization. Just might not find out about it.
Right.
I can imagine.
So you can see, yeah. So the point was your GraphQL should be more efficient in most cases. Maybe if you have a tremendously large database and you're not finding out the performance or scale issue until later. And I mentioned there's some GraphQL monitors as part of gateways to kind of see the performance. But I'm curious how that works in detail. Okay. Yeah. Okay. Yeah, so just to repeat that, the comment is that there are tools out there that analyze the performance of the query and send you back the information so that you could decide, you could take, do something about it to improve it.
And this is very much used. And I hear that it's really converts to develop faster. How easy it is to maintain this application? Okay, but if there were changes, then how fast, what would it be done?
So the question is development time. Is it worse, better, equal to arrest? It's a little bit better, a little bit quicker development time using GraphQL. That's interesting.
For us, adding different types of data, the effort for that is 35 magnitudes,
Okay.
and adding queries is 30.
Right.
We're probably cutting our development time around client server integration to probably a third of what we have.
Okay. Wow, a third of the time. That's GraphQL. Okay, yeah.
If you use that, number of databases.
Right.
If you do it as a tool, I'm not saying for example, you don't have to hand code all the schema. It actually renders a rough service also. And with a 5 or 6 seconds or in minutes of hand coding variable, you can just produce a service an hour or less.
Right. So yeah. So you're saying with some frameworks and traditional REST, it is pretty easy to do a lot of the stuff. Yeah. No, this is why we're talking about it, because some different opinions, and we'll see what people do. Yeah. Oh, sorry. Yeah, so you're saying for microservices, this breaks all of that, all this movement towards microservices and going one table per service. Right. Right. So we could have a different presentation on microservices when it's okay. So I'll take a few more, and then we could sit after and talk. Whoever wants to sit, because I want to initially apologize about the air conditioning. It was supposed to be on the whole night, so I apologize ahead of time. We'll take like 4 more, and then we'll stop for that.
What about security? REST APIs have a pretty well-defined vectors, parameters, and with GraphQL, you basically have an ASP where you could come up with all sorts of stuff. So, are there good tools for
like built into GraphQL or let it make it a role. Wasn't that something that you showed where it generated all the queries that are possible, and you would decide what you would allow?
Exactly, yeah. So you could limit, so in my example using Prisma and GraphQL Yoga, I was limiting, you could limit what you're making available to the client. So since people are getting up, any last question or last comment? Yeah, go ahead. Right, well, 15, it became publicly available, right, which is an eternity, right, in the IT world. That's a good question. I haven't looked like on Stack Overflow to see how many responses I get or whatever. I don't know. I mean, obviously by the people here, you've heard about it, and there's a few projects and you hear positive results from people. I mean, maybe it's not right, but you hear, hey, this is better than REST from a development perspective. Maybe it goes against some architecture, microservices architecture, but it seems like, and it does, harder to do. Does it work in the current architecture we're doing? So I don't know the answer to that. You know, maybe others here do. Yeah.
It seems more like it forces you
Yeah.
in a way that, like, if you use other servers that you set up, but, you know, we cheat. Like we'll have a bunch of routes set up, and then if you feel like there's something you need, then we add a couple parameters to respond in a different way. GraphQL seems like it forces your whole desk to be done.
Right.
You're locked in. And
right.
For some teams, it's better. For others, it's not.
Yeah. So the point is, it's locking you into convention. Right. Yeah. So the point was that you're locked into some aspect of convention with REST. You often want to go outside of it. And then the other point is, you're not really restricted. It seems like a convention. There is really convention over configuration, I guess, but you still could update resolvers to do what you want to do. Yeah. All right, so let me just so thanks. So I will post these slides. If you want to contact me through Solution Street or LinkedIn, we're always hiring. And thanks everyone for putting up with the hot air and from the speaker. Thank you. I knew you were going to be there. So feel free to stay around and talk and ask amongst yourselves here. So.
Very good, sir.
Thank you.